This video will cover questions relating to the topic of optimization problems. Two numbers. Question 1. Let the two numbers be x and y. Let's say y is greater than x. The difference is 80, so y minus x equals 80. Whose product is minimum? So we wish to find product p of the two numbers. When we solve optimization problems, we can use only one variable. Then y equals x plus 80. Then we can rewrite as x times y is x plus 80. Then expand x squared plus 80x. Then p of x equals x squared plus 80x. Then p prime of x equals 2x plus 80. To find the critical numbers, 2x plus 80 equals 0, then 2x equals minus 80, then divide by 2 on each side, x equals minus 40. The number line, minus 40, p prime of x. When the testing number is minus 50, then p prime of minus 50 equals, put here, 2 times minus 50 plus 80 equals minus 100 plus 80, which is minus 20, less than 0. It's decreasing. When the testing number is 0, then p prime 0 equals 2 times 0 plus 80, which is 80, greater than 0. It's positive, increasing. P prime changes from decreasing to increasing at x equals minus 40. That means there is an absolute minimum at x equals minus 40. Or we can use the second derivative test. P prime of x equals 2x plus 80. Then p second prime of x equals 2, which is always greater than 0. So p prime of minus 40 equals 0. Then p second prime of minus 40 is greater than 0. That means there is an absolute minimum at x equals minus 40. When x equals minus 40, then y equals, use this one, minus 40 plus 80, which is 40. So the two numbers are minus 40 and 40. Question 2. Find two positive numbers with a product of 108. Let x and y be the positive numbers such that x times y equals 108. The sum of the one number and the 3 times the second number equals x plus 3y. We want to express s as a function of just one variable, so we eliminated x in terms of y, which is x equals 108 over y. Then back to the original, x is 108 over y plus 3y. We wish to minimize the sum. Sy equals 108 over y plus 3y. Then we can rewrite as 108 times y to the power of minus 1 plus 3y. Then s prime of y equals minus 108 y to the power of minus 2 plus 3. That means minus 108 over y squared plus 3. To find the critical numbers, we equate the derivative to 0. Then minus 108 over y squared plus 3 equals 0. Then 108 over y squared equals 3. That means y squared equals 108 over 3, which is 36. Then y equals 6 or minus 6. But minus 6 is not the answer because y is positive. s prime of y, the number is positive, then 6. When the testing number is 1, s prime of 1 equals minus 108 plus 3, which is negative. When the testing number is 7, s prime of 7 equals minus 108 over 49 plus 3, which is positive. S prime changes from decreasing to increasing at y equals 6. Now we verify that y equals 6 gives the minimum value for s. Or we can use the second derivative test. From here, s second prime of y equals 216y to the power of minus 3, which is 216 over y cubed. Then s prime of 6 equals 0. S second prime of 6 equals 216 divided by 6 cubed equals 1, which is greater than 0. That means there is an absolute minimum at y equals 6. When y equals 6, x equals 108 over 6, which is 18. Then two numbers are 6 and 18. This is the third and last question. Two positive numbers have a sum of 36. Let x and y be the positive numbers, such that x plus y equals 36. Find the two numbers where the product of one number and the square of the other. So p equals x squared y. We want to express p as a function of just one variable, so we eliminate y in terms of x, which is y equals 36 minus x. Then back to the original, x squared times 36 minus x, then expand 36 x squared minus x cubed. Now p of x equals 36x squared minus x cubed. Then p prime of x equals 72x minus 3x squared. To find the critical numbers, we equate the derivative to 0. So 72x minus 3x squared equals 0. To factor, take out the common factor, which is 3x, then 24 minus x equals 0. Then x equals 0 and 24, but this one is rejected because x is greater than 0. And the number line is greater than 0. P prime of x, the number is 24. When the testing number is 1, then p prime 1 equals, put in here, 72 minus 3, which is greater than 0. And the testing number is 25. P prime of 25 equals 72 times 25 minus 3 times 25 squared, which is less than 0. P prime changes increasing to decreasing at x equals 24. Now we verify that x equals 24 gives the maximum value for p. Or we can use the second derivative test. From here, p second prime of x equals 72 minus 6x. Then p prime of 24 equals 0, and p second prime of 24 equals 72 minus 6 times 24 equals 72 minus 114, which is minus 72, less than 0. That means there is a maximum at x equals 24. When x equals 24, then y equals 36 minus 24, which is 12. Then the two numbers are 24 and 12. I hope this video has been helpful. If you have any questions, leave them in a comment. Thank you for watching. Please like and subscribe for more.